Work processes are broken down into one or more discrete steps. If Red 30 Tech's workers are assembling cat robots for sale, you could define tasks such as attaching the four limbs, the head, and also putting on the back. In this movie, I will show you how to characterize the time it takes to fulfill a task for one unit and how often the task will be completed on average. Those are referred to as the process time and the cycle time. I'll start in Excel using the O2O2 process and sample time workbook. You can find it in the exercise files folder. At the top, you see that I have the takt time, and that is the heartbeat of the process, how often you have to produce a cat robot to meet customer demand. Next, for each of the three stations that we're modeling, we need to know the process time, how long it takes to perform the task once, the number of workers that are assigned on average to the task, and then the cycle time. So we'll start with the process time, which we can just fill in. So for attaching the four limbs in cell C4, I'll type 330. Every 330 seconds, a worker will attach all four limbs to a cat robot and enter. The number of workers assigned to this task on average will be 3, and the cycle time is the process time divided by the number of workers. So in cell C6, I'll type equal, and then we'll divide C4 by C5, press enter, and we get a cycle time of 110 seconds. Now we can do the same thing for attaching the head and also the back. So in cell F4, I'll type in 210, and again, this is information that you discover by observing the process. Then in F5, we'll have one worker, so just type a 1 and enter. And the cycle time, although it is somewhat redundant, but I'll go ahead and put the formula in case the number of workers changes, is F4, the process time divided by F5, the number of workers, and enter, and you get 210. No surprise there. Finally, for the back, the process time is 60 seconds. The number of full-time employee or full-time equivalent workers would be 0.5, so one person working half-time. That means the cycle time will be 60 divided by 1/2, so I4 divided by I5 and enter, and you see the cycle time is 120. Two things to note. The first is that these values are just averages. There will be some variation. And also, if you look at 3 employees working on attaching the limbs, you won't necessarily get a cat robot with its limbs attached every 110 seconds, but you will, on average, get 3 every 330 seconds. So that cycle time or rate of 110 applies, but you won't get one at time 110, another time 220, and another time 330. All 3 happen at time 330. Right, so we have our information. Now let's switch over to the value stream map that we've begun filling out and add this information. Now I'm over in PowerPoint, and we have at the top right information from the previous movie, the demand, production time available per week, and takt time. Now we can add the information we just calculated for our 3 workstations. So remember that for the limbs, we have 3 full-time employees, and we have 6 people total. And again, this is something that you are told or that you learn through observation. For the head, we have 1 full-time employee, 3 people are available, and to attach the back, we have a half full-time equivalent and 6 people. So if we go back over to the limbs, we have a process time of 330, and again, dividing by 3 full-time employees, we get a cycle time of 110. For the head, it's 210 and 210, and for the back, it's 60 and 120. Again, 60 divided by 1/2 equals 120. So on average, every 2 minutes, a back plate will be attached to our cat robot.